air that flows over surfaces. Not yet. Oh yeah, you can start it.
Okay.
It simulates air that flows over surfaces, and for airplanes, these surfaces couldn't really move very fast on the plane, right? We could have control surfaces moving, but that was about it. We did not simulate extremely fast moving surfaces, just like for example propeller blades. Propellers was basically using just the old FSX based propeller system, which just calculates a force and applies it on a point. So for helicopters, obviously you need to have surfaces which can move fast, which can twist, which can flap, which can do all sorts of things. And so we've implemented that over the last months, and are starting to use it on airplanes. On Sim Update 8, 3 airplanes are going to get this on the base planes, and just one here is one example. So this simulates the propellers accurately, as if it was any other surface or the wing or any other surface of the airplane. So when the airplane is moving, you just get native P factor, you get all the effects, all the torque, everything is natively simulated and accurate. This fixes many of the last problems we had on the turboprop planes. So prop drag now works, etc., etc. I'm going to show a video later on that. So here you see just how it simulates the spinning airplane propeller. Propeller spinning way faster than the frames. So at the beginning you can see there's surfaces for each blade, but when it goes faster, it gets completely out of sync, and there's some basically more play. Yeah, the mesh changes, but also the simulation, just to make sure we simulate the entire movement and area of the propeller disc. You can see the force vectors slowly growing when it accelerates. So this is we can skip to the next video. Okay. This is showing the plane in a climb on the next video. So here you can see the forces are much stronger, and you can see how they don't really point forward, right? They're slightly off, because this is how, when the surface, just like imagine the propeller blade is a wing, when it goes through the air, the relative wind, it just creates lift into that direction and drag into these directions. So you can here really see the torque. So the King Air has 2 propellers spinning in the same direction, which means that the torque is not counted at all, and so you get a really strong P factor torque, and that you can really feel on takeoff on the updated King Air. This is really very strong. On the next video, just showing, well, if you have you will see what happens. So for example, here there's a feathered. So feathering now completely works. You can see that the propeller is completely stopped. And it's nice because it's a real physical simulation of the propeller as if it was a body. So now when I do rolling and banking, you will see how, because they are wings, you can see the little lift vectors, how the propeller stays actually, it doesn't rotate with the plane because, well, it's an independent body. I'm going into the cockpit. I'm going to change all the feathering settings in the cockpit, and then it's going to make the propeller spin. We also get prop drag now correctly works because, well, it's all really physically simulated surfaces. So everything that was hard-coded on the old propeller system that we reuse basically from FSX now is all natively simulating these effects. So yeah, prop drag, feathering, all the beta angles, everything that was really missing on the propellers is now simulated. So I'm stopping. You see, I'm stopping the right propeller, which is slowly stopping to spin. So even the spinning, how fast it stops spinning, this is all realistic. And you can see again the force vector, like the propeller now acts as if there was a little wing, adding, tiny bits of lift on one side. This system is open to plane creators. It's going to be documented. It's basically as simple as just describing how the wing is, how the propeller is the shape, right? It's just like the rest of the flight model. You describe the shape of the propeller, like the angle, how it's twisted, how aspect ratio, all sorts of different parameters, and based on that, the engine then computes the airflow around the propeller and simulates it correctly. So it was pretty easy to port these 3 planes. We could reuse the propeller settings and just adjust it to the actual shape. Another thing that's really, really important for helicopters is to have an airflow that is really simulated around the airplane and impacted by the aircraft itself. The aircraft changes the airflow, and on an airplane, there's a few effects like prop wash, fuselage shadowing, deep stall. There isn't that many. It's not that important, and it was hard-coded in the simulation. Now, for helicopters, we had to really simulate this realistically. But this benefits back and feeds back into the simulation of airplanes. So with Sim Update 9, we're going to open this on, again, a selection of airplanes. And also for a third party, it's completely flexible and can be parameterized. So there's a lot of parameters on the airflow like that you can adjust to control this and how it affects the different surfaces of the airplane. So here you can see, for example, the engine starting and how the turboprop engines suck the air in front and throw it backwards. You can see a little mini tornado on the right side, which is completely, it's just emergent because you can't really control what the air is doing. The weather engine feeds all the data into the simulation, and if there's a turbulence or a little gust or something, it's never really the same wind here. So see again the start on one side. So here, what you already see flowing here is already just the wind gusts that were there before, and when the engine starts spinning, it creates this airflow. So for helicopters, really important because there's all sorts of effects. When the helicopter is close to the ground, it creates vortex. We're going to show that a little bit later. But for the airplane, also quite a few effects. Here is in flight. You can see the propeller blowing air backwards, so it's green. And you can see the lift on the wings pushing the air down. And you can see how it not just impacts the air over the wing. I mean, when I'm going down, there's not much lift, but now it actually propagates, right? Because the air is pulled down by the wing, but then there's basically a depression on top of the wing, and so more air is pulled down. It really goes back like almost like a shock wave, but it's not a shock wave in this case. But it's just the propagation of the pressure is working like that. Here you can see I'm stalling, so there was a little bit of airflow detaching, and when you're stalling and the airflow detaches, this is going to hit the elevator actually, and so it's going to create native simulation of deep stall. Again, you can see the airflow on the wing, and when I'm trying to stall here, you can maybe see it slowly detaching at some point. There's also the flaps now, which are out, and I didn't stall this time. Oh, this is a same thing on a jet. So you can see the air is accelerated behind the jet engine. I think I'm stalling here too, showing because it's pretty interesting to see how the air detaches on the wing. And same thing, there's also when the air is detached, it's gonna hit the elevator here. Here you can see the airflow detaching and reattaching pretty quickly right now. And the depression it creates around the airplane. So the benefits for airplanes are native prop wash, native deep stall, native shadowing of wings. We get accurate calculation of the pressure changes over and below the wing, so we can calculate the temperature drops. So we get native calculation of condensation vortexes, or the wing tick vortexes. All these little condensations are going to be accurate depending on the weather, dew point, and humidity, and all this is now accurately available. And so for plane makers, what this is going to mean is there's going to be new variables where you can look up if you want to have basically like the temperature on top of the wing, and then you can inject that into an effect of, for example, of condensation. So this simulation for plane makers, you can enable it as a write only. You don't ever read back, so you can still get the condensation, pressure, all the effects, but it doesn't feed back into the airplane, so you don't have any impact yet. And then you can enable step by step the effects, and basically you can enable 90% of all the simulation feeding back into the surface simulation without really having to redo the flight model. The only thing that really changes if you feed back the vertical component into the elevator, you have to retrim. There's things like that, because basically you'll see it on the video that the air on the elevator usually goes down more because it's been deflected by the wing. And even though it's far behind, it's still deflected, and it's all being sucked down. So there's this change. It's usually half a degree incidence. So big benefit is prop wash becomes native. Instead of having to tweak it with parameters in the file, basically you can just now run the sim and you get accurate prop wash, all based on the propeller simulation. So here you can see how it spins around the propeller. It gets sucked in the front, accelerated by the propeller, blown backwards, and then we're going to turn around, show what happens. Basically, the prop wash impacts the plane, but it hits the tail, and so which not only deflects the air, but also it pushes on the tail. So you get this prop wash force on the control surfaces. Here you see I'm accelerating again, and you see the air rebounding on the ground, going back up. And now when I turn here you see when I turn the rudder, the air gets deflected on one side or the other side, and the air is pushed one way and the wing is pushed the other way. So you get basically you get the prop wash effect, which is simulated with this. And this is a free effect, right? It's easier even to implement on a plane than hard coding and entering prop wash parameters, like how much it's pushing left or right, and then you get all the effects that you have to enter. And here an advantage is it's melted into the weather. So if there's a very strong wind on one side, the prop wash is gonna be deflected on one side. It's much richer and more true to life than it used to be. So you can see I can use the prop wash to lift the tail a little bit. There's a whole bunch of new visualization tools which are coming. So this tool here is going to be available to visualize how the air is flowing. Even if you only enable the part of the simulation, if you don't feedback, you can still visualize it. This is one visualization which does not show the relative air speed. So it really only shows how the air is accelerated by the plane. And so basically this really shows how the wake turbulence is generated on almost any plane, but depends on the speed. But this one has a lot more, obviously, than a very small one. So one interesting thing here is we're going to use that to create accurate wake turbulence in the world, and this can animate effects like whatever. So ideally we want to fly through cloud and make it spin, but also dust which comes from the ground, all these effects. So here I didn't really do anything. I just took the 747, turned on the CFD, turned on the visualization, and it's raw out of the box, right? I didn't touch any parameter, anything. It just simulates it as it should. And what all this is going to lead into helicopters. So here I'm showing a little bit of a preview of what helicopters can do. So I'm using this one because it's already there, but you can see how in real time you get all the airflow. And here you can really see why on helicopters it's so important, because well, the helicopter is always creating airflow that interferes with itself. It's like a super prop wash, right, on an airplane, but completely changes the lift of every rotor here. And here you see when I slow down, now I get a vortex in the front, and this feeds back into the propellers, and so the air is constantly faster or slower, and the lift efficiency is always depending on what you did before, right? And you can see it's persistent, right? Depending on what I did before, the air is already impacted, and also by the weather, the winds, and the turbulences, and it feeds back. So it's much richer than a hard-coded effect on the helicopter, because depending on what you did on the ground, you're gonna run into your own vortex. You see here, they're going on the right. If I'm going back left, I'm running into my own sort of, it looks like a whirlpool of air here. But you see how it's much more impacting on a helicopter, especially if you're hovering close to the ground, than for a plane. And so this gives us, I would say, native and free simulation of ground effects, because, well, the air is bouncing off, so it's going slower, and you get the ground effect. You get here the vortices. It looks almost like a wingtip vortice when you're flying forward. And well, these are all native in the simulation, and this is basically really a preview of what helicopters are going to be later in 2022.
Thank you, Seb. And all of this is incredible. I think you mentioned it throughout your presentation, but when can we start to expect to see some of these changes in the sim and
So,
some of the planes?
Propeller update is coming with sim update 8. 3 planes. It's the Cessna 208 turboprop, the King Air 2 propeller turboprop, and the Cessna 152. And it's going to be available for plane makers, so they can just. I mean, I tested it on a few planes. You just copy the propeller block of the Cessna 152 on another piston engine, and because there's already usually the diameter and the moment of inertia is already there, and you already get 95% of the performance. So it's very, very easy to port. And then if you want to really do the fine tweaking, you can get it perfect. And it was the same for the King Air, right? Basically, you reuse the propeller of the 2.8 and had just to do a little, like 10 minutes of tweaking. So that's sim update 8. And this thing here you're seeing in front of us, this will be online on sim update 9. And we will start to basically same thing, open it on some planes. So some planes, instead of having hard-coded prop wash, will get native prop wash. And this will be available as a visualization. So this can be turned on any plane just to visualize, but it doesn't feed back. So basically you see the airflow, but the prop wash will not actually hit the tail, so it's not going to do anything. But you can still see what happens. And so the visualization is going to be available sim update 9, and this is going to be open for for plane makers from sim update 9 if they want to start playing with it and maybe same thing, have a native prop wash.
Awesome, thank you so much. That's really great especially for plane makers out there who are excited to use the changes here.
Maybe one more comment, because I was reading the chat and I'm very happy that you guys are as happy about this as we are, because I think it's awesome work. Somebody said, hey, you used to do feature discovery videos, and I just wanted to say, Seb, you're still planning on this, right?
Yeah, of course. Yeah. So this is just I mean, it's what was fantastic. It's so easy to make videos with this system because whatever you shoot, there's always like, so this little tornado which came up blue on the King Air video, I didn't expect this at all. And every time I made a video on shooting something, there's something new and something different. And obviously there's going to be feature discovery series, which a little bit more detail on how to use the system and more of the different, like maybe a stall or maybe what happens if there's wind and more different angles, like more, we'll have more time in the feature discovery.
Yeah, I think you scheduled it for February 7th. I just wanted to say, given how accurate this is, right? There's I would say just about all the world's aircraft manufacturers have taken notice how accurate the sim really is, and we'll have a lot more to say about this. But like, I think this shows you that this is about as accurate as you can make it, and we are closely tied to companies that make aircraft, big ones and small ones all over the planet. So I just wanted to mention that. Because sometimes people say, oh, this is more of a game than a sim. This is completely false. This is totally a sim.
Yeah.
And I think we're showing it now. Anyways. All right.